Okay, so now we move to question 12. Monochromatic line of wavelength is incident on a pair of slits brightened by 2.4 times 10 to the power of -4 meter and forms an interference pattern on a screen placed 1.8 meter away from the slits. The first order bright fringe is 4.52 millimeter from the center of the central maximum. Draw a picture labeling the angle and the legs of the right triangle associated with the first order bright fringe. Alright, so for case double slit, so we're going to have two slit lah. One slit, alamak tu cantik. Okay. Right. So two slit here. So this is our D. Distance between the two slit is our D. Okay, and then put away berapa meter tadi? 1.8 meter. So 1.8 meter. Alright, so your first order bright fringe appear here. So you label here as Y1 and this is the angle 1. Okay. Alright, so you may draw this way. Okay, next question is compute the tangent of the angle associated with the first order bright fringe. Compute the angle. So I compute the angle tangent theta. So tangent theta je lah. Tangent theta 1. Okay, so tadi macam ni kan. This is your theta 1 kan. Okay, so here is your y1. Here is your L. Okay, so how can we so masuk dalam equation tangent je lah. I mean your trigonometry. Okay, so theta 1 equal to y1 over L. Okay, so you may find your tangent angle theta tu. Macam tu je lah. And then say find the angle corresponding to the first order. Okay, so dia nak angle first order pula. So angle first order tadi tangent theta. Just now you get your tangent salah. We have find the value for the tangent theta 1, right? Okay, so we have the value for the tangent theta 1 is equal to berapa lah? The one that you get from the B question. And now you need to find the angle. Okay, so the angle. So you find your theta 1 lah by using your inverse tangent. Okay, your inverse tangent. So what's the angle? Right. And then are the sine and tangent angle comparable in value? Then to answer this, your angle to use in sine pula. Sine. So theta 1. So see the value. Is the value theta 1 is the sine theta 1 equal to tangent theta 1? Equal or not? So you need to check this to answer the sine and tangent of the angle comparable in value. Okay, so you compare these two. And then what can you say about this? So why is it the same, and why we can use the tangent? Since supposed to be we use sine, okay, but to relate it we use tangent also. Why we convert tangent and sine? Okay, this is because of the angle, is very small, so this will give a value that very close. Okay, so they're almost the same, value sine theta 1 and tangent theta 1, because the value of the angle is very small. Okay, dia sangat kecil angle kat sini, right? Okay, next question, calculate the wavelength of the light. Okay, wavelength of the light tu simply we can use it's up to you lah, use equation yang mana, ataupun we simply use the relation tu je lah. So salah pula. Okay, so d sin theta equal to your m lambda. Okay, so your m 1 lah kan, so find your lambda lah, macam tu je lah. Alright, and then next question is apa dah? Kau ada E E saya tak tulis, tapi E, alamak, tak ada pula soalan E. Okay, tak apalah. Okay, baca soalan E. E tu dia nak your angle for fifth order. So ambil je. So you already have your lambda, right? You have your lambda, you have your d. So simply substitute. You simply use your equation that you have to d sin theta equal theta 5 lah, to m lambda. Okay, so the difference here is your m lah, m value. So substitute 5 lah, and then d the same value, and you will find your angle. Alright, your new angle lah, sebab you need to find. So just now you only have theta 1, right? Okay, so you need to find the theta 5, where the fifth bright fringe appear. And then F, for question F, okay, you need to find the y5. Okay, you need to find the y5. Okay, so we can use equation, the relation with the tangent too. So L tangent theta 5. Okay, simple there. Alright, next, light of wavelength illuminates a slit. Okay, so this case a slit so bila a slit, the different tu dia ada white central bright fringe. So bila white central bright fringe, your first order adalah yang minimum. Okay, so here the value adalah 1 lambda. Okay. So what's the question? A, what is the distance from the slit should the screen be placed if the first minimum of the central is so given here, is your y1, is it? Okay, first minimum diffraction pattern is to be 0.852. Okay, so we have, for a slit kita ada equation ni kan. Okay, so y1 equal to L tangent theta. Okay, we still use the same relation. Okay, A L tangent theta. Since the theta is very small, so it's also equal to L sine theta. And when it become very small, okay, so or sine theta, okay, we replace with lambda over A. So ini bukan magic Yang ni adalah the trigonometry punya rule je. Okay, so lambda over A. Alright, so tinggal L. Betul lah. So sin theta lambda over A. So your Y1 equal to L lambda over A. Okay. So you need to find your L because dia nak apa screen. Where should the screen be placed? Y1 times A over lambda. So I think you have all the information given. So you find your L. So Y1 is your first reflection pattern to A is your single slit value, lambda is your wavelength, light of the wavelength. Next question is B. Calculate the width of the central maximum. Width of the central maximum. So we have Y1 kan. So central maximum kita dia macam ni. Macam tu kan. So this is your Y1. So Y1. So the total is 2Y1 lah. Okay, so 2Y1 equal to your width of your central maximum. Right? Okay. Question 13. So for this one is about photoelectric effect. Photoelectric effect. Work function for platinum is 6.35. So work function is your work function lah. 6.35 dalam EV. Convert to electron volt to joule. Alright. Okay, so use the conversion je lah. So you times dengan 1.6. So 1.6 ni apa? 1.6 of the 1.6 ni value of electron tau. Value of electron. So bagi balik dengan 1 EV, so that we can get the unit joule. Okay. And then B, find the cut-off frequency. Cut-off frequency. So frequency ada dalam equation energy sama dengan HF sama dengan sekarang ni dia nak cut off, so kita kena guna work function. So apa yang kita ada ya, HF frekuensi tak ada, yang ada is frekuensi tak apalah, work function ada kan. So work function lah, work function sama dengan salah, alamak. Okay, E sama dengan HF. Okay, so work function lah, maksudnya energy tu adalah yang sama dengan work function kita. So work function pula, cut off rate. Alright, so frequency akan sama dengan work function over Planck constant je lah. Okay, so that is your cut off frequency. What maximum wavelength of light incident on platinum releases photoelectrons? Okay, maximum wavelength tu we will get it from our cut off frequency lah. So cut off frequency tadi we get the cut off frequency, so our lambda cut off sama dengan kita kena buat equation yang ada, use the equation that have lambda. So we can relate using equation work function sama dengan HF. Okay, so this is also equal to macam mana kita nak relate dengan lambda. Okay, so frekuensi tu kita ada C per lambda. So H3 per lambda Alright, so work function sama dengan H3 per lambda equal to HF. Alright, so here we can find the lambda. So yang ni boleh cancel out and your lambda akan equal to C over cut off frequency just now. Right? Okay. Question D. If light of energy is incident on zinc, what is the maximum kinetic energy of the photoelectrons? Give the answer in electron volt. If light of energy incident on zinc, so that one is your E photon lah. E photon, so dia nak apa? Okay, maximum wavelength. So maximum wavelength tak, bukan D kinetic energy. Oh, KE je lah. Maksimum ni sama dengan, okay, yang ni kita punya E lah. Okay, E photon tu kita minuskan dengan work function dia. So berapa tadi? 8.5 EV. Okay, kita minuskan dengan berapa tadi work function dia? 6.35 lah. Macam tu je. And then give the answer in electrovolt. Tak apalah sebab boost dah dalam electrovolt. Okay, settle lah ya. E for photon of energy 8.5 electrovolt. What stopping potential? Okay, stopping potential is equal to EV. So it's just like your no, I mean equal to KE. So we want to find your V. So it's just KE over your E. Betul tak? Okay. So you just cancel out your E je lah. Because your answer for KE, you have find at D 2.5 EV, right? So you potong E tu lah. So you dapat your stopping potential.